apologize for the split in the video, but welcome back to my Standard 4 content and instruction. We're talking about algebraic concepts. In my artifact concept description 3, I discuss functions and how I would address the functions with the younger ages. I believe that it's important to start using functions as early as kindergarten, replacing numbers with blanks or question marks or even X's, so they get that a symbol, an X or a Y, is just a representation of an unknown. Some of the ways that I like to teach algebraic concepts is through doing a function machine, like a box where a student is hiding and we put in a certain number of items and they have a function or a rule that they keep, and they put out a certain number different, and then the class has to try and figure out what the function is. One way that I like to address algebraic concepts is by doing patterns in my classroom, and one of the ways that I do that is through a structure in my classroom called math stations. And at these stations I have different skills that they're working on, and one of the stations is always patterns. And I like this station because I can differentiate. I have cards that students can choose which pattern they want to build, or they can create their own pattern. That way I can specifically address kids that are needing to do simpler patterns, and then I can challenge those that are ready to move on to some harder patterns. Community problem number 4 addresses a mathematical scenario that I felt students in my classroom would be able to understand because of the context, and it also shows the relationship and how exponential growth works. I thought this might be a little bit challenging for kindergartners, but I was blown away at how easily they understood exponential growth, given that they're kindergartners. Anyway, take a look at that. Let's move on to the next content standard, geometry. In geometry, we're teaching characteristics and properties of 2- and 3-dimensional shapes. We're also discussing the location and spatial relationships of coordinate geometry. We cover symmetry, transformation, visualization, and spatial reasoning. In kindergarten, we're mostly working with using representations, building 2- and 3-dimensional shapes, mostly 2-dimensional. I like to use a thing called formations. It's a cooperative structure where students work together in small groups or whole class making shapes using a string or rubber band. In this structure, we discuss the attributes of the shape, the corners, the sides, etc. In using the structure formations, I like to create it or make it a problem-solving strategy. So I say, if I'd like to make a square, how many corners am I going to need? And my class has to problem solve to figure out, well, a square has 4 sides, so it must have 4 corners, and thus we need 4 people to make the corners. In my geometry portfolio, I address 4 different areas that I personally felt I grew in geometry. Communication is one, being able to communicate how I understood something with another classmate, so I was practicing my mathematical communication skills. I also share an artifact regarding connections, how I connected to other areas in mathematics. I also did one on reasoning, how I had to walk through step by step to reason my understanding of a certain concept that we were working on, and also a problem-solving artifact that shows how I problem-solved to get to my conclusion. To me, my portfolio shows an example of how I, as well, would use connections, representations, communication, reasoning, and problem-solving in my own classroom in geometry. Alright, let's move on to the next content area, data analysis, statistics, and probability. When it comes to data analysis, it's all about the question, being able to ask a relevant question that we can then collect, organize, and All About Me, where they'll be asking questions based on their favorite foods, how they get to school, how many siblings they have, that sort of thing. So they'll be coming up with a question where they ask that they can collect data on and then organize and present that data through a spreadsheet. My goal in that learning plan is that they will then make inferences and predictions regarding their data and then be able to come up with new questions. And statistics works the same way, being able to look at data that's already there and make the inferences and predictions based on that information. I love probability, being able to take an educated guess on what's in the bag or what's behind the curtain. In my probability lesson, you'll see that students have a chance to see representations, to problem solve, to do some reasoning, and prove why they think things are happening. To be able to they also communicate with each other, and it connects to the real world. Again, those are the skills that I see throughout each of my content strands as I teach my students and as I assess them. I'm looking for all 5 of those areas. I believe that reasoning and proof is the skill that can be utilized probably the most when it comes to probability. Students are trying to figure out how something is happening, and they have to reason and prove why something is happening more often or less often, and it opens them up for being able to communicate those things. Let's move on to the next content area, measurement. Measurement is a really broad content area. I listed a few measurable attributes: watts, distance, weight, speed, time, and volume, but there are so many more. I love the measurement content standard for its connectability to other content areas. For example, in the community problem 2, that's about going on the mileage club and walking around our track at school at recess. Also, I love to throw in measurement into science. One of the most tangible ways to research things is to see how long they are, how fast they move, or something along those lines. I have my students measuring their plants in the springtime. I have them weigh worms to see which ones are heavier and which ones are lighter. We also use measurement during reading. We measure how much time we're going to read for. Also, we use measurement in art when we're doing art projects to see how long we want something to be or how thick we want something to be. The best thing about putting measurement or tying measurement to other content areas is that students are forced to problem solve. They have to figure out how they're going to get the measurement that they want and which kind of measurement they're going to use. And then they often have to represent it in a way that they can share with their classmates and then communicate with their classmates the answers that they've found. Alright, let's go to the next content standard, calculus. So some may argue that calculus is not taught in kindergarten, but as I stated before, all of these skills build on each other, and there are some basic skills that students need for calculus that we teach in kindergarten. What you'll see in my lesson plan is that we use numeration, measurement, function, and relationships to discuss variables of triangles, the lengths of triangles, and also reasoning why some lengths won't work and some will. Also, you'll see in the place-based problem a similar thing, that it's functions at the root of calculus, and we teach functions even in kindergarten. Students are learning to problem solve through reasoning to find the missing function or variable. I believe for students to really understand calculus, they need to make connections. They've got to make those connections to the other math content areas that they've been building on through their whole math career. Okay, so let's move on to the next standard, the last one, discrete mathematics. So discrete mathematics basically is finite, anything that is non-continuous. To me, this content area is very much integrated with the other math content areas. So for my artifacts, I've given two problems that I felt were good examples of discrete mathematics. Shared problem number 2 is a problem regarding elimination. So three boys like different colors, and we're trying to eliminate each boy to figure out which color the last boy likes. To me, this is a good example of discrete mathematics because it's non-continuous. It eliminates as you go, so there's going to be one solution left in the end. In the second example, I use a Venn diagram of my whole class. So we have 20 students to start out with, and we're trying to figure out who voted for what. And again, this is discrete mathematics because it's non-continuous. You're dealing with one specific group, and it does not grow forever. So again, I really do feel that the most important part of discrete mathematics is its connection to the other content areas and teaching students that discrete mathematics is non-continuous problems. So this leads to the end of my presentation. I hope that you've enjoyed it, and